Well, good morning, everyone. Happy Saturday. It's November 29th. Tomorrow marks the third year anniversary of the launch of OpenAI's ChatGPT 3.5, which kind of kicked off a lot of craziness. And I'm reminded of a book by Eddington, where he wrote in this book about kind of the future and nonfiction and technology, all these sorts of things that were happening to humankind at his time, that the future is a foreign country. They do things differently there. And over the last 3 years, we've seen that everything is being done differently, right? I mean, you'd have to be under a rock if you're not aware of some of the things that are now happening with ChatGPT. What we want to do is take a moment to, in addition to introduce a bit about the book, share with you an overview of really what is AI and what AI is not, because there's some confusion there. And I think that kind of sets the stage for a number of other things we want to discuss with respect to kind of the history of AI and why AI now, why all the rage for AI today. We also like to walk you through something that we picked up over the last 3 years in terms of a pattern. My background is in Lean Six Sigma, as well as design thinking, first principles. And in the military, we use lots of checklists. So there's always this body of knowledge around things like Lean Six Sigma, and there's a framework. And with that framework, it's easier to understand how to solve complex problems. So we've essentially repurposed much of what we see in systems thinking, first principles thinking, and the Lean Six Sigma DMAIC process into what we call the AIM IT framework. And we're going to aim intelligent technology at the right problem. We like to also talk a little bit about prompting, right? In the military, again, the Air Force, we have a checklist. And so this checklist, I think, will be helpful for folks as you look forward to using basic simple prompts as well as advanced level prompts. Then we'll look at a couple of examples of applied AI and open it up to questions before we briefly touch on physical AI, which is really where a lot of the future is headed. At any point, if you guys have any questions, please feel just come off and mute, chime in with your question. It'll make this more interactive as well. Okay, so with that said, any questions or any comments? If no, we'll dive right into it. So the first question is, what is AI? Most of us understand AI stands for artificial intelligence, but what does that really mean? And how does that differ from other things we hear about? Right, we hear about things like machine learning. We hear these things called deep learning and networks. What's the distinction? Well, distinction is that artificial intelligence is the overall umbrella, right? It's the big picture. And it's any type of machine or system that can mimic human intelligence. Whether it's a chatbot or robots or game playing, we've seen chess go. We remember Jeopardy. I was with IBM when Jeopardy came out and beat Kasparov, the great chess player. So it can be used for different types of games and so forth as well. Machine learning, on the other hand, is really um, based upon data. You're looking at a subset of AI where you use machine learning to make predictions primarily. So it's a predictive engine used for recommendations, used to understand, anomalies in your email to determine if you're getting spam. So that's what we mean by machine learning. Much of what we've seen up until the large language models, ChatGPT 3 years ago came on the scene, was mostly a lot of machine learning. And a part of machine learning that has really taken off in the last few years, I would say since, probably roughly 2014, 2015, definitely by 2016 and 17, it was really gaining steam. But deep learning is more complex. What it tries to do is not just take a machine and mimic and predict things based upon data, but think about the way the human brain works, the networking of the human brain, and really mimic that particular approach to solving complex problems, more like we do with our brains. So we talked a little bit about what AI is, right? It's a system for mimicking human intelligence. We talked about machine learning algorithms or deep learning algorithms. We know that this complex neural networks is kind of how your brain works. But what is it not, right? AI is not just a tool. A lot of people just describe, this technology as if it's just some other random technology historically we've had as a tool. It's not the tool, right? A tool will not tell you to hammer with the nail, right? No hammer will provide you guidance. No hammer will take agency. On the other hand, with AI, it's not just automation, it can take action, right? And this has been one of the more recent developments that we've seen literally in the last year and a half. It's really became possible. And in the last 6 months, we've seen even greater breakthroughs with regards to what we call agentic AI. The two different types of AI regarding these large language models, by the way, relates to agentic versus generative AI. So generative AI is when we talk about the large language models, it generates some text, an email, an image. Um, and then agentic AI, which has really come on the scene more recently, is not AI that simply talks to you or knows things, but actually can do things, right? It can take action. It can create a PowerPoint presentation. It can go in, look at your email, summarize information, put together a report, send it out to people, right? It can take multiple steps, multiple actions. In fact, we've seen AI run now for a series of hours, in some cases as high as 13 to 30 hours, based upon certain um, um, remarks and benchmarks that have been revealed out there. So these things are really becoming extremely capable, but they're not conscious, right? They don't have sentiment. They don't have feelings. They don't suffer, right? They are not sentient beings. They are essentially a hoovering, right? A collection of all human intelligence picked up from books and libraries and the internet, um, and then compressed into these large language models that allow us to then interact with it in a way that it's essentially a cloud of words. We say one word, it can predict the next word because it's got kind of a cloud of words that kind of relate to those different words and it knows how to make those different connections. And so that's really how the large language model also works. The timeline of AI goes all the way back to 1947. In present day, here we are, November 2025. Some of the key milestones, stones you guys probably heard, the Turing test. This is one of the key individuals that really set the tone coming out of World War II with the Enigma machine to help break the code of the Nazis. That is really what kind of kicked off a lot of what we see with respect to um, back then they called it computer intelligence, but artificial intelligence. Later, the term was coined by John McCarthy. This perceptron that we see in 1958, that's essentially what you're seeing on the cover of the book. So if I could, you'll see here the caveman is in his cave, and this little fire element, this is the perceptron. So we wanted to kind of bring this into the modern age and connect it to the caveman. So that's what we mean by the perceptron. The perceptron was really important because this is the first time we started thinking about how we might be able to mimic the human brain versus just mimic human intelligence and predict like we did in the past. Over time, there are a lot of what they call AI winters. We had successes and then we had failures. Um, but by the time we got into roughly about 2014 timeframe, right? You can see all these convolutional neural networks. These are when we got a lot of the deep learning breakthroughs that were happening. And then the seminal point was in 2017 with Google's paper, Attention is All You Need, in 2017. That was essentially the transformer they came out with. And that's the same transformer when we look at GPT, that T stands for transformer. Google came up with the idea, but OpenAI was the first to launch it and go public. And that's what brings us here to present day. We can see all of these major advancements that have taken place since November 2022, which is that again that 3 year anniversary of AI. So why has everybody been so, excited about ChatGPT in general? The biggest reason is because literally within 60 days, it was able to attract 100 million users. And previously, Spotify took almost 6 years, Instagram, 2.5 years, TikTok, 9 months. So the fact that it reached this point in 60 days got a lot of attention. Today, that number is approaching 900 million weekly active users on the platform. So it's a major, major advancement with respect to value that people apparently are getting out of it, um, as well as probably a lot of entertainment and fun things they do with it as well. So why suddenly now? We talked about all the AI winners. We talked about all the challenges with AI. Why suddenly is it working today? Primarily three reasons. One, massive amounts of data. As we pull together more and more, data that's associated with logs for everything you do online, all the machine language information that comes off of different machines around the world, all of the large ERP systems and manufacturing execution systems and laboratory information systems and CRM systems, customer relationship systems, and then, of course, social media, the explosion of all the phones, all of that has contributed to this amazing amount of data. Um, and when we take this data and combine it with compute, primarily NVIDIA, which has gone from 1 million to 2 million, and then just recently from 3 to 4, I'm sorry, to 3, 1 trillion in value to 2 trillion. Then more recently, it's jumped to 3 trillion, 4 trillion, and just last month, it hit $5 trillion. It is the number one provider of these graphical processing units. We've heard about computer processing units. A graphical processing unit, primarily used by video games, was found to be able to parallel process and crunch through this data in a way that we've never been able to in the past. So when you've got the compute, you've got huge amounts of data, and you improve these algorithms, particularly at this transformer, what has happened is that's been kind of the secret sauce that's led through the major breakthroughs that we see today. Some of the current tools out there, I'll just share with you this screen. Many of you are familiar with the large language models, whether it's Gemini, Claude, or ChatGPT. Tools like Microsoft Copilot, Jasper, Midjourney, Ideogram, Suno for music. And then there are a number of different productivity tools like Notion, AI, Grammarly. With respect to AI code assistance, we have Cursor and we have the vibe coding tool called Replit, which we use quite a bit. And then there's things like search, right? The new searches that have come out, such as Perplexity AI. And recently we've seen new AI systems roll out, both from Google as well as OpenAI and others. And finally, there's specialized tools. For example, if you're in the legal industry, Harvey, um, or open text if you're in the healthcare life sciences industry. So a lot of these are just a list of some of the tools that are out there. Obviously, these things are exploding in volume literally every day. More come online. We obviously could never um, keep track of all of these changes, but this is where we've discovered people are getting now extremely confused. They don't understand the distinction between all the AI. Why is it working today? Why does it not always work the same way? When I give it a question, it gives me different answers, right? All of those challenges have forced us to take a little time to start seeing some patterns that we can share with people. So, for example, generally, if you're doing things around software development, Claude um, has been proven to be the best. It holds that distinction consistently. Anytime someone comes after it, it launches a new model literally within days, many times, and shows it's still the leader. Gemini, go ahead. Question, comment. Okay. Gemini 3 is really great for research. It's got, it's all the Google data from its 25 years of history. So online behavior and all these things it's able to do very well. You've heard of VO3 with video. You've heard of Nano Banana with images. And then more recently is added the ability to do agents. So powerful tool that's been rolled out by Google just recently with Gemini 3, ChatGPT 5.1. Um, Generally more of a consumer product that gets a lot of attention. They've got enterprise versions as well. But in terms of scalable, simple, easy to use application, a lot of people love ChatGPT for that reason. They say that over time it gets to know them and they feel very comfortable with that particular um, sense of kind of a friend or a partner when they're chatting. And then also Claude is known to be quite creative, particularly Opus 4.5. So we're looking at narrative and copywriting material. Also, it's recently rolled out Claude Skills, which is a really great advantage, and we've been using this quite extensively. Let me pause there before I move to the next section. Any questions about kind of just the background on artificial intelligence, right? The big picture is AI. It's anything that mimics a human brain. Machine learning uses lots of data to make predictions. Deep learning tries to borrow from the way the brain is structured. And that is what has led to the transformer, which is the T in GPT. Um, it's not just another tool. It's not just automation, right? It can take action. It has agency. Um, and we see the milestones, this more than 70 years, 75 years ago, more than that, we've seen ChatGPT, or we've seen this evolution that has brought us to ChatGPT. So AI is not new, but the recent developments have been just stunning and amazing, as we've seen from the graphic with the 60-day adaptation of 100 million users. Questions? Very good. So we're going to switch gears and talk about what we call the AIMIT framework and some of the foundational elements that tie into that. Now, earlier I said that this is getting very confusing for people. There are new models, there are new apps, there are new breakthroughs in AI that happen literally every day, and it's becoming overwhelming. Most people just are saying they can't keep up with it. They're choosing to bow out. We highly recommend you don't bow out. Rather than worry about all of the noise, what we're trying to do is help you cut through the noise by identifying a few things that if you pay attention to, a lot of other things will kind of fall into place. And that's what we mean by our AIMIT framework. And of course, AIMIT is an acronym. The A stands for assess, then innovate, model, implement, and track. At a high level, we're trying to assess the current state and define the problem that matters that we want to focus AI on. We want to define the goals. We want to make sure that this could be a potential area where we can scale so we really can get ROI, not just something that is an individual productivity gain. We innovate by looking at everything that we assessed in terms of our current state, all the problems, process steps, and pain points and root causes. We bring that over into innovate. We then brainstorm on those root causes. We come up with 7 alternative solutions for each of the root causes. And these are both AI-powered traditional methods of solving problems, as well as the new generative AI or agentic AI solutions for solving the problem. From there, we try to figure out the right AI model that will work. In some cases, maybe it's just a proof of concept that we want to develop with just a RAG system. Retrieval augmented generation is just a way of connecting your domain expertise to the large language model so that the large language model stays grounded in your company's information. Um, Custom GPTs, it could be an AI agent or it could be some sort of AI ML model. So these are all the different kind of rough categories of different models that can be used to solve the problem. So what we do is we proof of concept, we create a minimal viable product of that in the model phase. Once we have that up and running and working, we then scale that into production with implementation. This is where we're now looking at the model. How do we integrate it with all the data? How do we integrate it into our workflow? And then how do we make sure that we help people adapt to the change? As we roll out this new technology, there's going to be training, there's going to be new documentation, SOPs. There's probably going to have to be a bit of organizational change management and communication to help people adapt to the change. And then finally, we monitor and track the model because these models will drift over time. As we mentioned before, they're not deterministic. You don't always get the same answer every time you put a prompt in. So consequently, with things like AI evals and DSPy, we are able to monitor and identify and alert when these models drift out of a particular range. Our AI capabilities. The AI capabilities was designed by looking over 3 years of working with clients as well as our team members, many of which are on the call. And just my own personal experience applying some of these things. And we identify these patterns, right? So one is kind of the human AI collaboration. This is, you've got to build trust. You've got to help people adapt. You've got to help them upskill and then show them how to use AI, how to use prompts. And many of the conversations we're having right now ties into uh, that human AI collaboration. You may have to implement organizational change to help people adapt and move forward. Content generation, that's the ability for these models to generate anything from text to content briefs to uh, full reports. They could be generating images, they could be generating videos, audio. Um, Vibe coding or code assistance is the capability of these agents now to take code and allow us to use normal, natural English language or whatever your native language is to essentially code, to get the machines to do what we have that we want them to do without having to sit down and code. It takes our information, our text, and it converts it into whatever code is necessary. And we've used this for some of our applications. Problem solving, this is the AIM It framework. We talked about it before. The 5 steps. How do you look at a problem solving approach that is relevant and flexible enough for the change that we're seeing with artificial intelligence, data infrastructure, and analytics? Once you get ready to deploy these systems, you're going to have to put in place a lot of AI data and infrastructure to make these things work. So this is where we address that. And then the back end of all that data is how do we analyze the data to make good business decisions, make smarter decisions, drive actionable insights. We earlier talked about RAG and search. This is like enterprise search, searching inside your company as if your company was Google. So you can find information really fast. On average, company individuals spend up to 15 to 20 percent of their time every week searching for information that they can't find within their company. So this has dramatic productivity gain when you can do this well. And if you can connect the large language model using this RAG system, again, this retrieval augmented generation. So it retrieves information for your domain, it augments that with the large language model, and then it generates a better response that's grounded on your domain expertise or your company's knowledge. Deep research. We mentioned this earlier when we talked about Google. Google has a very powerful capability when it comes to searching and research because it's been doing this for 25 years online. So deep research is a powerful tool that can save you literally hours or days of time conducting research. We use this frequently when we're deep diving into any of the new advances in AI before we take that information, simplify it, and make it digestible for our clients and begin to apply it and share how we applied it with our clients as well. And then finally, physical AI. This is where things are moving in the future. We'll talk a little bit more about that in a moment. Any questions on the AI capabilities, right? So again, what we're trying to do is rather than chase a bunch of rabbits, we're trying to say, here are some foundational things. If you have a problem-solving approach and you follow this method consistently, the AIM It framework, right? And if you combine that with the proper use of AI capabilities, whether it's data infrastructure and analytics, content generation, or deep research, you'll be able to take the concepts of AI and focus those on specific areas where they're useful to you versus chasing a lot of things that come up every day in the newspaper. Additionally, we have the AI, 4 AI core capabilities. I won't spend much time on this. Pretty straightforward. First of all, you want to have a strategy for yourself or your company. What's going to be your personal area of expertise within AI? You can't do everything. Just as we saw those AI capabilities, no single person is going to become, an eminent authority in every single one of those. But you can select 1 or 2 areas where you want to become gain mastery and become known in that particular application of AI. Make sure we then connect to AI ethics and governance with whether it's within your organization or just for yourself. Have something around character that's important because one thing AI can't do is build trust. So this really becomes your competitive advantage if you can build trust as you take advantage of the AI tools. Once you've got a good direction set, go out, develop your skills in terms of technical and logical capabilities. We'll talk more about some of these in a moment. Develop good critical thinking skills and pattern recognition in terms of how these models work. And then never forget the human element, right? Start with you own the large language model. The large language model does not own you. You create the problem. You generate the request. You ultimately own the output and must confirm it, review it, evaluate it, judge it before you present it to other people. Umar, yes, please. Saw a
Hey,
hand
I have
up.
a question around the security part. Where does the security concern come in? Because when we develop these applications using the LLMs, there is a big concern regarding the security. So, how does that part tie into all of this?
Yeah, very good question. It typically falls within the AI governance. So governance is kind of a general catch-all phrase. It typically looks at everything from bias of the large language models, privacy, security, all the many times companies will kind of combine the ethics and governance a bit together. But typically this AI governance is where we do that in terms of strategically. And then with respect to the AI capabilities, it definitely falls in the data infrastructure because this is where all your AI infrastructure and data, you obviously don't want to leak private data, student data, healthcare private information data. So it falls into both this area as well as strategically under this ethical AI governance section. Great question.
Thanks for enlightening that.
You're welcome. Okay, so in addition to the AI capabilities and these AI core competencies, there's the mindset, right? And we believe this is probably one of the most important things because you can teach people some of these competencies and these skills and how to take advantage of these capabilities, but if they don't have the mindset, if they're not fearless, if they're not relentless, if they can't adapt to change and they're not curious to take the initiative to use the AI, they're not going to benefit, right? So no amount of technical know-how will make up for a lack of a good AI mindset. So as I said before, AI prompting, there are a lot of mistakes that many people make and they get frustrated and aggravated with these AI models. So here are a few things from the perspective of a former aviator. And this is me flying with one of my buddies, David, out in Colorado, fighter pilot, really amazing guy. I'm not as good a pilot as this guy, trust me, nothing near, never have been. But it's always nice to be around great people like Stillwell. So, what do we find when we think about this from the perspective of a checklist? There are a lot of things that can go wrong. That's what we just call a failure mode. What goes wrong with these AI tools, these large language models, when we chat with an AI like Claude or ChatGPT or Gemini? First of all, they'll over elaborate, right? Um, they by default will assume to be more helpful. So they'll embellish, they'll flourish. They'll ornate, they'll add more information than you need, right? In fact, sometimes they'll tell you more than they know. So the countermeasure for this is be explicit in terms of minimizing what you want it to do and giving it constraints. Otherwise, it'll continue to tell you things that are irrelevant for what you're trying to achieve. The more you give it some guardrails and constrain it, the better off you are, right? So many times I might say something like, hey, listen, here's a paragraph I just wrote, improve the grammar, and then summarize this with, two sentences and three bullet points, right? And then you constrain it. You tell it exactly what you want. Otherwise, these models will just, right, they can be very verbose and they'll just continue to talk, right, and respond back. And by the way, that just is, particularly depending on the model you're using, it's using up a lot of energy. That's wasteful, right, to society, but it's also taking up extra time. You're, running through what's called the tokens, and you may run into a token limit, and then you're not being very effective in terms of taking advantage of what you need for the model, as well as not being, kind of a steward of our ecology and our ecosystems. So context collapse is another thing. What do we mean by this? Unfortunately, the large language models, right, forget. You put in something, the next time you come in to prompt it, it's forgot everything you said. You have to reprompt it, right? So this context collapses. It doesn't have that ongoing memory. So you've got to make sure that you treat each prompt as if it's a standalone. And in some cases, and certain models behave a little bit differently. One of the things I do notice with Gemini, it will tend to, if you ask it a question or if you load information like an image, you ask it to do something, and then you say, repeat that and do this, it'll forget what it repeated, right? What does repeat mean? It doesn't know. It's just going to do whatever you just said in the last part of your sentence. So I feel, many times I will literally tell it, read all the text above, and then respond back, repeat this for in this way, right? Um, so in other cases, you just have to open a new prompt. Depends on the model in terms of how much you'll have to do that. Pattern matching, again, they match patterns really well. And in fact, they have all this training data. So like we were saying before, if you're trying to force it to constrain itself to a specific domain expertise, it's always going to resist this. It's going to go back to all the general information that's in its training model. So the way to do that is to make sure that you demand, for example, sources, right? So it can't go out and just continue to expand and use internet information, some of which that information is incorrect. You demand it to provide the right resources, the sources, so that you can look those up and confirm it. And you tell it to reverse its logic. Critique yourself is a simple thing you can do with the large language models. Um, Before you prompt, define what do you want, right? This will really save you a lot of time. Um, if you want something, where you don't want to have gradients in the colors, just say no gradients. Don't say make it professional, right? Professional can mean so many different things, even to so many people, right? Let alone a large language model. Use visual examples. So many times I'll just give it an image and say, do it like this, right? Except change this color. And then build constraints, based prompts, kind of like we said before. Again, narrow its solution space. Tell it to give you something in a specific way. Umer, did you have your hand up? You have a question?
Yeah, I do have a question for the previous slide. If you can go back. Yeah, I have seen that with a couple of my friends and also my own use cases that sometimes we build the custom GPTs using the context. And what we have seen that if the data that has been provided is not filtered or is not good, it might end up hallucinating. And most of the time, it's being said that, your chat model is hallucinating, whereas at the root cause of that, most of the time, it's the data because it couldn't find the latest pricing, latest quotes on in some cases, and then the model starts to hallucinate. So if you could just enlighten that part in the failure modes.
So one of the things we'll see this quite frequently. Many of our clients, they'll be using a custom GPT. There's a toggle when you develop a custom GPT. What do we mean by custom GPT? The custom GPT just means that rather than you chatting directly with the chatbot, you're creating kind of a subset of that chat bot that you feed it data. Could be like 25 different HR policy documents. It could be financial information, could be contracts, could be legal information. And you're essentially trying to ground that large language model to that context of that domain expertise that you have. Okay. However, one of the things that you can do is if you give it the option to also search, then what it will do is if it can't find the information, or even if it finds the information in your PDFs or all your language, your information, it'll combine that with information online and it'll mix it up, right? And you'll get hallucinations. And so we typically will tell folks to shut that toggle down so it can't do search or restrict it only to the content that it's looking at within your company. Those are some of the ways that type of thing can be addressed. That's a really great question. Okay. Um, so those are some of the things you want to do right up front. Define the problem. What are you really trying to do with the prompt? When you're executing, be systematic, right? Um, Give it steps. Um, Test it out in real conditions because whatever you do with a large language model, just within that little prompt is one thing. But once you start testing it and scaling it and having other people use it, you're going to find that you're going to have to make adjustments, right? We've done this a lot as we made for different large language models, create PowerPoint templates. And each one works a little bit differently. So it took a lot of iterations to find a template that worked for all of these. And then once you do that, create a system so you're not having to go back and work from scratch and reinvent the wheel each time, which is another example of what we did here. We refined for both all these PowerPoint slides you're looking at is based upon code that we developed with AI to write our PowerPoint presentations, right? We gave it all the content, all the background information, we gave it the structure. So this literally saves us hours and hours worth of time. We can literally create 10 to 12 slide presentation with reusable systems in 5, 10 minutes, sometimes 15 minutes if it's a 20 slide presentation, but you get the basic idea. And then, like we said before, post-flight check, verify you own the outcome. It's not a large language model, right? You can't go to any executive and say, and your boss and say, here's what the LLM gave me, right? It's yours. It's your ownership. You have to double check things. Mathematical errors are very common. Citations and facts, something you definitely need to double check. If you're in a regulatory compliance area like healthcare, life sciences, financial industry, double check very carefully to make sure that compliance is understood. And when it comes to strategic recommendations, it just doesn't understand the politics. It doesn't understand all of the myriad events and things that are happening that impact strategy, right? They're psychological, they're economical, they're technological factors and things at place. It typically does not understand how to pull all those things together, and particularly not within the context of your specific problem or your organization. So be careful about strategic recommendations. Okay. So I think you basically get the point. We have things like redundancies that we also put in place. And we talk about examples where you don't want to use AI, for example, information that's proprietary, um, health information on individuals, emails on some of your key people within the organization that should be limited to remaining private. Okay. Three basic rules around prompting, right? Be explicit in terms of what you want, be precise, give it examples, show it images, um, give it step-by-step actions to take. Um, Understand you'll never get it perfect, iterate. And if you get something at 70, 80, 90% good, right? Well, guess what? That means you're still human. You can add value with the other 20%. Don't think you should be trying to get an 80, a large language model to give you 100% outcome, right? Verify, as we said before, to make sure that whatever you get, you've checked yourself. Okay, we're going to switch gears now and just talk about two different examples of how do you apply this in real life. We'll use the example that I use both previous to COVID. I use this Rios Cafe, but during COVID, working with a lot of clients, we turned this into the COVID example of Rios Cafe. So this has been a case study that I've been using for at least 25 years around the world with different companies, and we've upgraded for AI. So in this particular case, it's during COVID. Rio's Cafe sales dropped 70%. They've got 6 months to turn things around, or they're going to have to close shop, right? So they have to put together their goals. They need to figure out who's going to be their executive sponsor, who are the core team members. They may have to have some extended team members to support them, and then they identify the timeline because they've only got 6 months to turn things around. From this project charter, they look at the process. They want to understand the journey of the guest. They are at home trying to decide should they go out to a cafe or just stay home and make their own coffee because of the COVID, not wanting to go out. They arrive at the cafe, they place their order, they make their payment, they wait for their pickup, and then they depart, hopefully with a nice cup of coffee. Some of the pain points that happen during these different steps in the process are shown here below in this orange ochre color. So, for example, entry and arrival, they may fear crowds because of lack of social distancing, and they may have people in their family who are susceptible highly to COVID based upon perhaps some of their current chronic medical conditions. Okay. So we identify those pain points, and we bring the pain points from these process steps over, and we cluster those pain points together into common elements, and then we go through a root cause analysis. The advantage of this is many cases working with clients, we will have 30, 50, 80 different pain points, and now everybody's chasing all of these pain points. Better to identify the common themes of those pain points, pull the common ones together, and then go through a why root cause analysis. So fear of infection and crowd distancing. Well, why is that? Because they're too close to others. Why are they too close to others? Because there's a small lobby area. Why is there a small lobby area? Because we've set this up in order to queue for registering, right? Well, obviously you can change this around. You don't need to make it small. You can have it outdoors. You can have a drive-through, right? So this then begs the possible solution to the root cause where you have a bottleneck. And then we repeat that. So now instead of chasing 15 or 20 different things, we're only chasing three or four root causes. We take those root causes and we brainstorm solutions for those root causes. We call this the seven alternative solutions exercise. We try to figure out both AI-enabled traditional methods that we could come up with, as well as completely new generative AI and agentic AI types of tools that can be used. Brainstorm those solutions. We'll come up with three or four for the client to kick things off, and then we force them to brainstorm the rest of the solutions. We then take these solutions and we put them on an impact matrix. So high impact means that this can really help us a lot in terms of turning things around and hoping to make sure that Rio's Cafe doesn't get shut down. And then effort is along the bottom. Effort is time and cost and resources. So those things that are high in impact but low in effort in this quadrant would represent things we can do very quickly. We call those quick wins. On the other hand, maybe there are things that take a lot of effort, but you don't get a whole lot of bang for your buck. Then this would be one of those things we probably don't want to work on. It's a thankless task. And then we may make strategic bets on major projects that we think it's worth investing in, particularly the supply chain during COVID was a mess. So we may come up with a supply chain prediction algorithm. Remember that machine learning we talked about before? Using data to make predictions. So this could be an algorithm. You use AI to help you do it so you don't have to pay for expensive data scientists because this can be done with AI today. Then we model. We try to figure out what models work best to solve that problem. And so this is where we're seeing whether it's a co-pilot with Microsoft or it's a voice chat, right? Maybe an AI voice chat for customer service. That's where we figure out what particular AI model we should use based upon the solution we're trying to provide. And then finally, last two steps is now we roll everything out. We implement it into our data and into our workflows. And then we evaluate to make sure that the model doesn't drift, it doesn't hallucinate, it stays on track. Okay. Umar, are you in a position you want to touch on the AEGE, or you want me to briefly go through those? Okay. So many of you have heard this thing called SEO. It's search engine optimization, but because of large language models taking over a lot of the search, people don't search, right? They want an answer. They don't want to search. So a ChatGPT system bot will just give them the answer. So why should they search? So this is what's changing the entire internet. It's called the zero-click internet. That's evolving before our eyes. So the question is, are there a way of doing agentic or what we call generative engine optimization or artificial engine optimization type of approach to SEO. In other words, what's the next phase of search online? And so here we notice that organic traffic is scheduled to drop by 25% on all the websites by 2026. That can have a dramatic impact on the feasibility of your business to stay in business. So we identify that as the problem. We try to figure out, given objectives, what might we do? We go through the same process we talked about before. We map out the process to figure out what do we do? We research, right? We draft the skyscraper. We publish an index. We track to see if these blue links are ranked high on Google. And then we search, we analyze the data to figure out if we're getting high click-through rates, high conversions, high number of sales online, right? So we know the process, and then we identify the pain points. Again, we take those pain points and we do a root cause on the pain points. So now we're focusing on a few things that we can really affect. And then once again, we brainstorm potential solutions associated with these pain points. Content isn't machine readable. So a large language model can't read your website because you have not converted it to what's called machine readable. Okay. So these are examples of some of the new potential solutions. Again, we do the same thing. What are some quick wins? We just improve the schema on our website, and that'll have a really big impact, right? Doesn't require a lot of effort, but it has a nice impact and a great quick win. And then finally, as we did before, we now have to integrate this with all of our data and all of our workflows and put in place our evaluation system so we know if things are going off track and if we're achieving our goals based upon our project charter that we identified at the very beginning. Okay. We'll just show you one more example and then we'll open it up to any questions you have. So here, physical AI working with one of our clients. This is really kicking off to be a big area. So before we had these human in the loops. Human in the loop means it's more like digital work. You're watching and overseeing it. But as we move into beyond this industry 4.0 into physical robots and what's known as digital twins, AI factories. What we're trying to do is get AI to act autonomously and do stuff, right? We're not just trying to have it, write a report, write a respond back to a chat. We want it to actually do stuff. So here we talked about agentic AI. From all the examples we've already discovered, right? Whether it's software, content generation, or RAG, or creating AI agents. But now we're moving into physical. The physical is where we create a digital twin. So we essentially grab a bunch of data, we grab everything we know about our company, and we create a simulation of that company working in a virtual AI world. And what that allows us to do is simulate different things. What happens if customers' volume increases? What if happens if supply chains fall in one area? What happens if humidity goes up or the temperature changes? Or what does that do to our production line? So this is the new area of what is being referred to as physical or industrial AI, where now we're trying to apply AI to the physical world. We talked a little bit more earlier about generative AI and agentic AI. No reason to spend any more time on that. But now what we're trying to do is get these models not just to learn language, but to learn physics, right? It's one thing to learn how to say something and predict the next word and therefore be able to respond. It's something else to understand the physics of our three-dimensional world and it moving through time, right? Things moving through time as well. So the digital world is where this digital twin, like we said, we create a mirror of the organization, but the world model is an abstraction, right? It's like what we carry in our heads. We, without even looking around, we know, there's a wall behind us. We know there's a window over here, right? We have a sense of everything around us. We know that if this cup was to tip over, it would spill, right? We have a model of the world. What we're trying to do now is create AI agents that have a sense of the model of the world so I understand the physics of what we're dealing with. Now, with respect to tools that are being used, I'm not going to spend much time on this. We'll pass this out. People can read this at their leisure. But there are a number of different ways for doing this for physical operations using lane chain, innate and crew AI. Each of these just represents a different way of handling movement, action, agentic behavior within a manufacturing industrial type of a setting. Innate is great for workflow, triggering an event and sending some sort of alert like an email. And then Crew AI is really good when you want to simulate different individuals. So in sales and operations planning, you usually have competing interests. You have a salesperson that's trying to maximize sales and would love us to have as much inventory so his customers are always happy. And then you have an inventory manager who has to minimize inventory, right? Because otherwise you're paying for all this capital costs and it gets very expensive. So you create a third role that kind of manages and facilitates the trade-offs to optimize both sales and inventory. This is one example of NVIDIA, how they've done this for different clients. They create this omniverse, this kind of this factory layout in a virtual world. They can identify thermal flow. They can figure out where robots should move around in the factory. All of these things without putting a single dollar of investment into physical assets, right? So they can simulate all these things well ahead of time. And then this is one of our favorite, Boomax, our client with Strain Labs. They've essentially, they're out of Europe, Sweden, and they put a sensor inside their bolts. So now, rather than having to go out on big bridges or big structures and test for structural integrity and put people's physical lives at risk, these things will sense the change in structural integrity of that bolt and will alert you. So this is just the whole new world that we're moving into as we think about physical AI. Well, listen, we've gone through a number of different things. We first talked about an overview of AI. We talked about some frameworks like the AMIT framework for problem solving for AI. We looked at some examples um, of different ways of prompting, and then finally, specific applications in use cases, whether it was Reels Cafe or the online AEO GEO world, and then finally, a bit about physical AI. So thanks everyone for your time. Please let's take some time, take a moment and wrestle with some of these things a bit. What's on your mind? What's a challenge as you guys are looking at AI? What's confusing? What are you learning that you can share with others? Please take a moment. Let's have a conversation. Thank you. By the way, thanks, Dad, for showing up. I've got my father online. He's the smartest 88-year-old AI expert I know. So.
Yeah.
He's smart. He's smart. He's smart. He's smarter than many 28-year-olds as well, by the way, when it comes to AI. Very proud of him. He's always pushed me for when I was young, a young child, right? He brought me this Welo magnet thing, right? And I started understanding how magnets works. And then from magnets, I understood electricity. Electricity brought me into computers and electrical engineering, which took me to the Air Force Academy and brings me back full circle here today in front of everybody talking about artificial intelligence. So thanks, Dad. Thanks for showing up.
Hey, thank you for taking patience to uh, help me to learn a little bit. It's well appreciated.
Yeah, no, we just continue to be inspired by what my father does. And I think all of us should be working with our family members any way we can, right, in our communities to help them understand what's happening with artificial intelligence. This is going to, unfortunately, it's going to be devastating for many people. The transition over the next 1 to 5 years is really going to be devastating. Most people have no idea what's ready to hit them. I go back, I look at many of the companies I work with over the last 30 years. Literally, I've seen literally people committed suicide. I literally took them down, right, uh, from a noose. I saw people that you thought they were going to adapt to change, and they never came back to work again. I saw people during COVID, right, just devastated their families. Um, the financial crisis, 9/11, COVID, these are just like small ripples in the pond compared to the big tsunami that's going to come with AI, right? So we want to make sure that everybody's prepared and we're reaching out, helping people and preparing them.
All right. So you mentioned your dad. I do have my daughter sitting with me. She's the smartest AI expert that I know, just 7 years old.
Uncle Frank, I am missing as
Oh, hey, you called me Uncle Frank. How you doing?
Uh,
No, she's
well. I'm
really
good.
sharp. I'm good too. Thank you.
It was a good session.
Oh my goodness. Well, thank you very much. We have, the authority right there. So if she says it's true, sounds like we did okay. Thanks for preparing, helping us prepare. I think someone else was ready to say something.
I do have a question around the digital twin that, first of all, AI has made the digital twin part easier by coding and building the simulation of the models, or you can see the products and services you're offering. But how does that benefits the industries, as an example, the manufacturing industries, and how they can actually leverage? Because I have been with a number of clients, and the only solution that they can think of quickly is just making a couple of chatbots or, a couple of more small solutions, but a lot of them are confused at the broader level how they can actually bring in the AI to help them predict their sales part or predict the supply chain, and also help them during the disruptions. And if there are some areas where AI can actually help them in the manufacturing part as well. So
Yeah. It's the way that I think it's important to think about a lot of this. Earlier, we talked about, right, this big picture AI, right, mimicking human intelligence. And then down inside the circle of that, we talked about machine learning, which is using lots of data to make predictions, right? And then the third level is deep learning, right? Something like a large language model, like a GPT, ChatGPT, that really mimics the way the brain works, right, to solve a problem, not looking at a bunch of data alone to make predictions, right? Um, I think it's important to start with that second circle. First, you got to grab lots of data, right, of your company, inside your company. Many times I go inside of companies and I literally look at all their major processes and I grab all their data and I want to know all the data for each of the steps in the process, right? Because if I know, okay, so many customers, the weather is this, we get so many customers at this temperature with the weather at this time of the year. They follow these steps in the process in terms of us making something for them. We send it out to them. It takes a certain amount of time before they receive it. They give us feedback. We take that feedback, feed it back in to our next product. Now I've got all that data. I've got data on all those steps in the process. Once you have all that data, you can take a model and it can look at all the patterns in the data and it can make predictions. And so, therefore, once you do that, now you're in a position to leverage that with AI to say, okay, what if I do run different scenarios? If my humidity, if my temperature, is at a different level, what do I know from looking at all my historical data, the impact that has on my production and my output, right? So now I'm simulating this with data. And then what you do is you take all that data, you put it in a virtual environment, and you make a three-dimensional flow of your operations. But between all the steps in the operations, you're using data, right? AI data and patterns to make those predictions. And so once you get to the point where you can say, okay, if I make some assumptions that I do this, this, and this, and I run these different numbers, okay, here's my assumption that the temperature was this, that we had this many customers come in, and we had a supply chain problem. And I run that with the data, and it gives me an answer. And I go back and I look at my historical data when I had an event like that, and it matches or it's pretty close. We know the model's working, right? That's the power of it. And then from there, with artificial intelligence, um, building these world models is really on the cutting edge, right? This is what you're going to see a lot happen in 2026. We're not there yet, but it's happening very quickly. That is where we'll then be able to understand the physical behavior, right? Everything from friction um, to touch, tactile uh, um, features and so forth within the actual manufacturing operations, right? So now we're adding another element and three-dimensional and time, right? We're not just bringing just raw data and making it just on the predictive data. We're now taking that raw data and kind of exploding it into three dimensions and move it through time. That's what's happening right now with these world models, the whole physics of how the companies are going to work. So it's still early in the cycle, but we're beginning to see a lot of that happen. For those of you who are familiar with Fei Li, she created a thing called a company called World Labs out in San Francisco. They just rolled out a tool called Marble, Marble. If you hadn't had a chance to look at that, look at what that thing does. What it does, most people look at it and they think it's a video, but it's not. You put a prompt in there, you don't get an image or a video out, you get a three-dimensional virtual world, right? So she's on the cutting edge of this, and all the manufacturers are looking at how they can take advantage of that technology that she provides. Okay. So early days still. Okay. I want to be respectful of everyone's time. It is a Saturday, but anyone have any other questions or any other comments? We will make sure you guys all get a free copy of the book. Thanks for attending today's session. You guys have a great rest of your day, Saturday. Enjoy your holidays, and thanks for showing up. Bye, everybody.
All
Thank
right.
you.
Thank you. Bye-bye.
Bye.